Yo! Our look at circular motion and gravitation will be quick because, here's an object moving in a circular path. Yeah, object moving in a circular path, all right? At any moment, and this circular path has a radius r, sure, and let's say the thing is going around this way. Make sure you can identify the fact that the velocity at any instant is tangent to the circle. Make sure you can identify at any instant that the net force is inward towards the center. And make sure that you can identify that the acceleration is inward towards the center. That's what we call it, centripetal acceleration. All right? A couple things you'll be asked to do. Probably calculate the acceleration and or calculate the net force. Well, that's still ma. The centripetal force uses a centripetal acceleration. So the net centripetal force is mc. Here's a, v squared over r. You might have to do that. Okay? Things moving in circles. Objects moving in circles. All right, a couple cases. One, an object in orbit. Well, gravitational force is the centripetal force, or weight force, which is a gravitational force, is the centripetal force. That's why planets are able to move in their orbits, because of the gravitational attraction between the sun and the planet. Okay? Two, car on curve, centripetal force is friction. Without friction, cars can't turn. Friction between tires in the road. All right? Three, swing a ball on a rope. Centripetal force equals tension. Yes? Roller coaster loop. Centripetal force equals normal. All right? Not sure what else really we need to talk about there. All right, gravitational stuff. All right, definitely be able to do this. Here's M1. Here's M2. These, as we said before, these objects exert a force F on each other, equal and opposite. All right, and that's assuming they're separated by a distance r. Okay, if we did, how about this? 2m1 and m2 at the same separation. Well, this would now be a force of 2f, and this a force of 2f. Right? We doubled one of the masses. That makes the force twice as big. All right. The other one they'll ask you is something like this. What if we did this? M1, M2. Now they're at a distance 3r apart. Well, the forces are now F over 9. F over 9. We're using this. G, M over R squared. All right? It's easy enough when you change the masses to figure out what happens to the force. But when you change the separation, be very careful, because what you do to the separation is squared. Its effect on the force is squared. And it's also what we call an inverse relationship, because if r gets bigger, F gets smaller. Okay, but don't forget the fact that it's squared. So whatever you do to r, do the opposite, right? Bigger, smaller. Do the opposite, but squared. Okay? That's why, notice, r got 3 times bigger, F got 3 squared times smaller. Yes, we've seen that 50 or 60,000 times this year. All right, I think that'll do it. Don't forget the units of this. But I don't know the units. That's okay. They're on the reference table. Write them down exactly as you see them. Okay? Okay. Goodbye.